Alright, good day. So we continue with the rules again because like I said, this topic has a lot of rules that you're responsible for. Some of them are very basic rules you'd have come across before, but some of them might be new and we didn't reach the advanced part with Pythagoras' theorem and the trig ratios yet. That'll be coming up soon and that'll be trigonometry. So we're still on geometry here. These are some more geometry rules. Total interior angles and shapes. Now it's something you mightn't study, but this is where the maths part gonna come in as well. So any three-sided shape, a shape with three sides, what's the name for a shape with three sides? A triangle. And different names we have, different types of triangles, equilateral, scalene, and so on. We'll be looking at those a little bit later. And how much the angles inside a triangle will add up to? 180 degrees, same amount as a straight line, by the way. What's the general name for any four-sided shape? Now, a shape with four sides is not a square or a rectangle or a trapezium. Those are types of four-sided shapes, just like equilateral, scalene, and right angle are types of triangles. So the name for any four-sided shape, again, you realize tri means tree, angle means angles. Any four-sided shape, quad means four, and the lateral means lines. So a quadrilateral, like a square, rectangle, parallelogram, rhombus, all of those are types of quadrilaterals or four-sided shapes. And the angles in a four-sided shape is 360 degrees, which just so happens to be the same amount in the circle, by the way. Right, just for reference. And we can keep going. Now, they really don't give you more than 5 shapes, but you would every so often get a shape with more than 5 sides. What was the name for a shape with 5 sides, though? So a shape with 5 sides, penta means 5. So a pentagon is a shape with 5 sides. And just to clarify and double check, after 4 sides, all the shapes have the same amount, 360, or as we add more sides, the angles get increased as well, the interior angle. So the rule is it does increase. So every time we add a new side, we actually increase by 180 degrees because a straight line, which is what we add every time we put a new side on a shape, brings with it 180 degrees. So that's how you'll see our next pattern. So if I'm just going to add in one more here, a shape with 6 sides, call that a hexagon, and it will again go up by 180 degrees because that's the pattern. Every time I add a new side, you realize this increased by 180 because a lot of stuff in maths would have patterns. So if I went again, the next shape would be 900 and so on. We keep adding. So there actually is a formula. So if we had n sides, the formula is 180 degrees n minus 2. So if I had a shape with 3 sides, that means n will be equal to 3, just to show you how the formula would work. So in this formula, it will be 180 degrees, 3 minus 2. 3 minus 2 is 1, 180 by 1. So that shape, which we call a triangle, would be 180 degrees. What if I had a shape with 5 sides, which is the pentagon that we just looked at? So that means n is 5. So 180 degrees, 5 minus 2, which is 3. 180 by 3, 540. So this is just a general formula. If we had an n-sided shape, 180 degrees n minus 2. Now again, this doesn't come up often enough, but you never know what CXC going to bring in any particular year. So let me see how these rules going to come into play. Mainly would be with triangles and some 4-sided shapes and some 5-sided shapes, as you'll see when we're looking at some of the past paper questions. But let me start basic and see how it works. So calculate the size of the following angles. I have a triangle. They give me 2 angles. I want to find the third. So that's just basically this rule here, which again seems very simple. So all 3 of them want to buy something. It's coming up to 180. He put up 50. He put up 60. How much he's supposed to put up? So both of them so far put up 50 at 60. So far both of them put up 110. So he have to put up the balance because everything costing 180. So to find out how much he has to put up, 180 take away 110. So he puts up 70 degrees and that would have been my answer. Right? Because everything in here have to add up to 180. I add up what they put up so far and I subtract to get the balance. Come like we want to buy a pizza. The pizza costing 180. I put $50, you put $60, we get the third person. Hey, we short. How much I need to put? You work, add them up, subtract, I get my 70. Next idea, realizing now it's a little different because even though I have the triangle, I draw an extra line outside and I have an X outside the triangle. But because I have a straight line and the straight line is going to get cut by a next line, we have that straight line angle forming here. These are things you have to notice. So that very first rule going to come back into play now. And that very first rule was angles on a straight line. You realize you don't really see where the rest of these lines go in, but it could be joined onto a shape, like in this example here. So if I could get this angle, then I could get this angle here because they have to add up to 180. So let me see what's going on so far. So let me find this third angle in my triangle first, because I could actually find all my angles in the triangle. 70 at 30. So far they put up 100. A triangle is supposed to add up to 180 though. So how much more I need to put to make up 180? So 100 add 80. Or in other words, 180 take away 100. If I wanted to show working, I'm going to give me the 80. So 180, we finished the triangle part, but I didn't want this angle. I wanted this angle out here, but I needed him in order to get here. So because these are on a straight line now, I know both of these have to add up to 180. So if he put up 80, he's going to put up 180, take away 80, so x is going to be 100. And as a general rule, if we have this situation again, these two angles always total that angle there. But it's something you could work around instead of remembering an extra rule. So that angle works out to 100. And again, we're going to incorporate more rules now. So I have my triangle, but because these two lines are parallel, traveling in the same direction would never meet, now I could incorporate my parallel lines rules. So I have different rules I could use here. I could use angles on a straight line. It's upside down this time, but all three of them on a straight line, meaning all three of them have to contribute to the 180. But so far, he put up 65, he put up 75, 75 at 65. 140 when you add it up, so he have to put up the rest. 180 take away 140, 40, right? And again, you could do your working and check it yourself. At this level, you should be able to see 75 at 65 is 140, and then 180 take away 140 would give me the 40 when I work it out. But that didn't really help with these, but what's going to help with these is the parallel lines. And first thing I look for with my parallel lines that I like to look for is that Z shape. And I do have a Z shape with the parallel lines. And what does that mean? That means these two pieces are going to be the same. And just like that, with alternate angles, I get here is 65. And now I can add up these two and get this. Or, if I realize that, hey, I have a back to front Z here as well, because the line's still parallel. So him and him going to be the same. And however you do it, these are going to be the triangles that you needed in this one. I want to look at types of triangles now, and the different types of triangles we're going to have since it's related. Just some rules. Again, you realize there's more rules again for you to learn. First type is the equilateral, and in the equilateral, like the name says, equi means equal lines. All of them have the same lengths, and to let me know, just like parallel meant arrows, to let me know things have the same length, you'll see these little cuts in the line. So when you see those little cuts in the line, whatever have that same cut in it, all of them will be the same length in that particular example or question. If it have more than one line that equal, it might have double cuts on them, as you'll see with some others past paper questions later. So in the equilateral, everything equal, all sides equal, all angles equal. But if all angles equal, then how much each angle going to be every single time? Well, I take the 180 and I split it into three pieces, so all angles will always be 60 degrees. So mathematically, it have little I could do in terms of calculations with the equilateral, if you realize, because everything equal. The isosceles, however, is one of the most popular for geometry. The right angle will be for trigonometry, but for geometry, the isosceles is the most important. Meaning they get the most questions from. And in the isosceles, two sides equal and two angles going to be equal, but you have to know which two sides equal, which two angles equal, because it's not just any two angles going to be equal. Opposite the equal sides, and that's why I like to draw my arrows. So opposite this equal side, this angle facing it, and opposite this equal side, this angle facing it. So these will be the two equal angles, and we'll come back to some questions on this in a little while. The scalene, in the scalene, nothing equal, and you might feel like, well, what we could do without it nothing equal. In fact, you could do plenty. In this example here, all these were scalene triangles, by the way, because nothing equal, no angles equal, no lengths equal. So you would get questions on the scalene. It's just it have no special rule with it. We would have been doing what we did here, where everything add up to 180, but nothing going to be equal, right? That's all it is. And in the right angle triangle, we have one angle equal to 90 degrees, which is the box. That's the right angle where the triangle going to get its name from. And the side opposite to this angle is the longest side of this triangle. So opposite to this angle, we have the longest side of this triangle, and the fancy name we give to the longest side of this triangle is the hypotenuse. And you'll see this more a little later when we're doing specifically questions related on the right angle triangle. So just like before, I want to look at some questions on the isosceles mainly, because like I said, that's where most of the questions going to come out from in this topic for geometry. So just like before, I want to find the sine of angle x, and the rule for the isosceles triangle, if you remember, two sides equal, two angles equal. And the let me know which two sides equal because it have these cuts. So opposite this side going to be equal to this side. So since those two sides opposite each other, they're going to be equal, so x is 40. And that's it. Once a number rule, it's that straightforward, but they could have variations as you will see. So in this next one, you realize I used the double cuts this time. That means it would be part of a bigger diagram and they had more than one pair of lines equal. So they had to indicate that. So just like before, I like to draw my arrows. So opposite this side and this side, these two equal. So that doesn't really help me directly with x, but it will help me eventually. So if here is 50, opposite here going to be 50. And now I could use my rule for triangles. I know a triangle have to add up to 180. So both of them put up 50 at 50. So far, both of them put up 100. How much more he need to put up to make the 180? 180, take away the 100 to find the balance. So he's going to be 80. Seeing how the different variations come. What about this one? So just to make sure you was paying attention, it's not always the two bottom angles that equal. It may look like that, but it's where the equal sides are. So here and here not going to be 70 because the equal sides not here again. So like I said, wherever the opposite sides, wherever the angles are to the opposite equal side. So opposite this equal side is 70, but the next equal side is here. So opposite him going to be up there. So here going to be 70 as well, and that's my answer because I draw the triangle differently this time. So once it's looking like that, it will be the two bottom angles, but this time it was looking like that. So always follow the two equal sides to get your two equal angles because the orientation could change sometimes. Last one. So in this one, opposite the equal sides, the angle is going to be equal. So opposite here is x, so opposite here is x. But that didn't really help because I still have two unknowns now. But what I do know is, in a triangle, all three sides have to equal to 90. So this is where some of the algebra is going to come in. So that means x plus 120 is equal to 180. But x at x is 2x. So 2x plus 120 is equal to 180. Carry across the 120. So 2x is equal to 180 minus 120. So 2x is equal to 60. So that means these two angles, which makes sense, because if he put up 120, both of them together have to put up the balance, which is 180 take away 120. So both of them have to put up 60 together, and both of them putting up the same amount because they're splitting that 60. So x going to be half of 60, which is 30. So he's going to be 30 degrees, and he's going to be 30 degrees. And let's just double check. 30 at 30, 60 at 120, 180. And for all of them, you could double check. 50 at 50 is 100, at 80, 180, because a triangle is supposed to add up to 180. So we finished some of the basic geometry pieces. We'll do some past paper questions soon. And next up, we're going to start introducing the trigonometry pieces.